Let's take a look at a conditional probability problem. This is coming from the Open Intro Statistics 4th edition book. And let's do this. Look at this predisposition for thrombosis. Okay. A genetic test is used to determine if people have a predisposition for thrombosis, which is the formation of a blood clot inside a blood vessel that obstructs the flow of blood through the circulatory system. Doesn't sound good. It is believed that 3% of people actually have this predisposition. The genetic test is 99% accurate if a person actually has the predisposition, meaning that the probability of a positive test result when a person actually has the predisposition is 0.99. The test is 98% accurate if a person does not have the predisposition. Okay, so then what is the probability a randomly selected person who tests positive has the predisposition? So this is a problem that uses Bayes' theorem to answer it. And I have created a little a Bayes' theorem calculator on StatPowers where you can build a probability tree. Let's take a look at how we would answer this using that tool. So first off, there are for the first variable is thrombosis. We're gonna start by just labeling the different variable outcomes. We either have the predisposition or no predisposition. There's only two outcomes, and we have either a positive or a negative test result. The math is the same whether or not you label the outcomes, but it can make the tree makes a lot more sense when you label it. All right, so we have the blank tree now, and we can start adding some probabilities. It says that there's 3% of the people have the predisposition, so that's what we want to start with, 0.03. And as you enter it, it's going to calculate the complementary probability. Anything it can calculate for you, it will as you enter the data. The next thing it tells you is if a person has the predisposition, then the probability of a positive test result is 0.99. So I'm going to put that in here, the probability of a positive test result if they have the predisposition. Now clicking out of this, it's going to calculate everything else in this part of the tree. And going down here, if somebody does not have a predisposition, it says that it's 98% accurate, means it will give a negative test result with a probability of 0.98. And again, clicking out of here, it's going to finish calculating all the probabilities in the tree for me. So now the question is, what is the probability a randomly selected person who tests positive has a predisposition? Now this is the default. Here down below, the probability of predisposition given a positive test result is already calculated, 0.605. That's a 60.5% chance. So that's how we use and if you make a mistake with your tree, you can just click clear all and it clears the whole tree for you. And if there's more outcomes, you just say there's 3 different outcomes for variable A or 4 or 5. It will just keep building the tree bigger and bigger and bigger. And once it runs out of space, it'll just make the space larger. So this would absolutely never happen in an intro stats course, but if you happen to have 19 different outcomes for your first variable, you can build that tree, although that will never happen. And that is the Bayes' theorem calculator.